so we're in the part of the school year where we would be getting out the graphing calculators and we would start practicing how to graph some of the equations we've been working on a graphing calculator. At school, we would be using a TI calculator, but since we don't have that access to those, we're going to use an online graphing calculator, which is just as good, called Desmos. So all you're going to do in Google is just do a Google search. We'll do Desmos graphing calculator. And your screen might come up where it says start graphing, and you'll just click on that. From the screen, you can start to graph equations. You'll notice that there's some buttons over here on the side, and they let you zoom in and zoom out. So I thought it'd be kind of cool if we graphed some of the quadratics that we were solving last week. So one of the quadratic equations you solved last week was as follows. So I'm going to type in and just start with y equals. But if you notice down here, there's a keyboard that you might want to pull up. You can drop it down to and just use your regular keyboard. You can use X on your keyboard or the X here to square that. If you don't have that keyboard pulled up or you're using your phone, well, let's just go with this x squared, then minus 6x plus 8. And we have our parabola. And from this graph, we can see the solutions. If you hover over these dots, we can see the solutions are 2 and 4. We can also see its minimum point occurs at 3, -1. Another cool thing that you can do is just click any point on this, and it'll give you non-integer points, so decimal points, and then if you drag, it'll trace the shape of that graph. So if we wanted to do another graph, we could do a couple things. We could just click here, and it opens up. See how this is red, and it corresponds with the red line? If I typed in another equation, this time let's do -x squared minus x plus 6. And now, because this is blue, our line is blue, it corresponds with that color. And I can tell on this one that the x-intercepts, or the solutions, are -3, 0, and 2, 0. And once again, I can trace that, and we see that it has a point of intersection. That's kind of cool. And trace it and see all of those points. So you are going to be using the graphing calculator to match equations and lines. And this happens in your book. The assignments that you're going to be doing is page number 78. So I'm just going to do one of those problems with you. So number 14, for example, the equation is y equals 1 divided by x. And that's what that graph looks like. And you can tell that this graph, if you're on page 78 in your book, goes with graph G. So the answer to 14 would be G. And you'll just do that for each of the graphs on problem 14. I'm going to X out of this. And I'm going to show you on question number 21. The first one is just part A, says which equations represent linear, quadratic, or exponential functions. So you might be able to look at the equation and tell, but you could also type in the equation. So let's do y equals x squared. This is 21, 1 plus 8x. And right away, I can tell that it's quadratic because it's in the shape of a parabola. Also, just so you know, you can drag on your screen if it's or zoom in or zoom out. So that's the first equation. I'm going to leave that one up there. And now I'm going to graph number 5. So number 5 on 21, 5, the equation is y equals, so we'll go ahead and type that in, y equals x times the quantity of x plus 8. And close that out. And you notice that it is right on top of our other parabola. And the reason it's right on top of that other parabola is because these two equations are equivalent. So question 21b says find any equations that represent the same function. Well, we found one, equation 1, and this is equation 5 in that book. So that might help you do question 21A and B. The other thing that I want to show you is how you can insert a table, and this might help you on some of your warm-ups. So instead of an equation, if I insert a table, and let's say I'm given the points 5, 2, and we'll do 8, 12, it plots those points. And from those 2 points, you might be able to draw a right triangle to find, and use Pythagorean theorem to find the distance. This might help you write the equation for a line. So I just wanted to show you that there were other options besides just